this is the line tracker. So it's not attached to a vehicle yet, obviously, so I'm just going to describe the state as if it was. So then, as you can see, over here are the 8 sensors. The first 3 sensors are described by the 3 green wires over here. The middle 2 sensors are described by the 2 blue wires over here. And then the most right side 3 sensors are going to describe be the red wires over here. So left 3 wires are green, right 3 wires are red, and the middle ones are blue. So the way I did this is that I grouped the 8 sensors into 3 groups, right? So the first group is going to be the left group of wires, the middle is going to be the blue, the right is going to be the red. The reason why you group them is just in case like the line isn't perfect, and then like it's easier to know when it hits a group. So obviously it's going to turn left when the left group of sensors are on. It's going to turn right when the right group of sensors are on. So it's going to go forward when the center group of sensors are on. But if the line tracker does span, let's say like these 2, it would still be going straight. The reason I did this is because obviously there's going to be a transition time when the line is curving. So at one point it might span both of them, but I reasoned that it would not be sufficient enough to qualify as a turn if the line was only curving a little. So only when the line truly shifts to like the entire right sensor, let's say, that's when it would start turning right. Now, each of these the way I grouped these sensors is by using AND gates. The reason why AND gates are useful over here is that the tracker goes forward, or it senses a tape when the sensors go down to 0, right? So in this case, all high would mean that there's no tape. So then as soon as one of the sensors go down to 0, aka it senses a line, then that means the whole group is going to go down to 0, because that's how an AND gate operates, which is useful over here because it operates on low. Now, each one of these group of sensors then goes into into registers, right? So the reason why I have 3 registers is because I have 5 states. I have the states go forward, turn right, turn left, intersection, turning left, and stop state, which is 5, which means it requires 3 bits. So that's why I need 3 registers, and the output for each register is going to go into a bit of the state. These light bulbs are gonna indicate what state it's in. So like, let's say if the bulbs are all off, and that means go forward. If the bulbs are like, let's say 1, 0, 0, aka the left one is lit up, then that means it would mean it's at an intersection and should be turning left. Or at the first time it's hitting an intersection, it's turning left. So if you look at the states over here, the reason why I distinguish between just a normal turning left and turning left first at intersection, there's 2 reasons. First of all, it's just that it's easier that way, since the intersection, at the first intersection, that's the only time it's going to be turning left, and the other intersection is going to be going forward, right? The second reason why is because the intersection turn is actually it's going to be a harder turn than just going around the figure 8, because it's more at a right, the turn's going to have to be more at a right angle, which means it has to turn not necessarily quicker, but turn more sharply. So the way I distinguish this is that for the normal left turn, only the right wheel would be turning and the left wheel would be staying still, which would be allowing it to turn. But at the intersection, to have a sharper turn, not only is the right wheel only turning or moving forward, but the left turn is actually going backwards, which allows it to more spin, the vehicle to more spin in place, to make it successfully make the turn. So the way the registers feed into this is obviously there's just a bunch of AND gates, OR gates, XOR gates, NOR gates, etc. that make it so that when the when the left group of sensors is on, it would output a 0, 1, 0 to make it turn left. When the right group of sensors are on, it would output like a 0, 1, 1 to turn right, etc., right? So that's essentially how it operates. The way I made it turn left at an intersection for the first time and then go straight for the other time, I'll explain once the circuit is actually on, because it's easier to see that way. So now I'm going to show the vehicle in operation, aka the power supply is on. Okay, so ignore this light for now, I'll explain it later, it's relevant to the intersection. But anyways, you can see, so right now, let's say all the sensors are at a high right now. So that means it is not hitting any tape, right? Because it's not hitting any tape, as you can see over here, the bulb is off, on, which is a 001, which means it's in the stop position. So it's as it should be. Now let's say the tape has now hit the middle sensor, right? It hits the middle sensor, and now everything turns off, because now it's 0, 0, 0, it should be going forward. Everything's as it should be. So now let's say the tape is starting to curve towards the right. So obviously the right sensor is going to go into a low too. And even though technically the tape is spanning both the right sensor and the center sensor right now, it's still at a forward position, right? It's still going forward because I don't think like just because it's hitting part of the right sensor and still hitting the middle sensor, the tape isn't curving enough to qualify it for turning right. So now let's see what happens when the middle sensor goes to 0 and only the right sensor is on or is hitting the tape. In that case, then it finally shifts into a new state, which is 0, 1, 1, and 0, 0, 1, 1 means it's turning right. Everything's as it should be. Now let's say it's going back into the center stage. It's going back into the center stage. All three of these are off, and now let's say it's going into the what do you call it? Okay, now it's going into the left state, right? So now the left sensors are sensing the tape, everything else is not. And as you can see, we have a 0, 1, 0, and this 0, 1, 0 means that it is turning left right now. Okay, everything is as it should be, that's good. Now, let's say we hit the first intersection. So the way the intersection works is that when all of these sensors go into a low, then that means that the output, the state is going to be a 1, 0, 0, so that means it should be turning left at the intersection. But it's only going to turn left at the first intersection, right? It's going to go straight for the second intersection. And the way I did that is by using an SR latch. So essentially the way that works is that this actually represents the output of an SR latch. As soon as the vehicle turns on, it's going to be in the set position, which is the reason why the output is on. So actually as soon as the vehicle hits the first intersection, which the vehicle knows when the state turns into a 1, 0, 0, because all the sensors are 0, 0, 0, then that means it's going to reset the SR latch. So when the SR latch is reset, then this bulb goes out into a 0, and when this goes into a 0, that acts as a memory of the fact that it has already passed the intersection for the first time, and it's going to be going straight for the second time. So once that happens, that's essentially how the SR latch works. So let's see it in action. So right now it's in the turning left state. Let's say it hits the intersection right now. So this left is going to stay as a low, the middle is also going to be low, and then the right side is also going to be low. And as you can see, as soon as the right one also went low, this bulb went off, so the SR latch has been in reset position, and also the state has turned into a 1, 0, 0 state, which means it's turning left at the let's say it's going forward again. So going forward again means that all the sensors are off except for the center one, so now it's at a 0, 0 state. Now let's say it hits the second intersection again, right? So when it hits the second intersection again, it should still stay in the 0, 0 state because it's going forward now, as we know, because this register, this SR latch's light is off now, which means it already passed the first intersection. So let's see, I'm changing the wire over here to make it hit the first to hit an intersection. Now all of the sensors are at a low. As you can see, the going forward is still the state it's in because, yeah. Okay, and that is essentially how it operates. Oh, by the way though, I'm going to shift all the wires so that it's like it's going forward again. What's interesting is that I also thought there might be a mistake in the sense that it accidentally thinks it's passing the first intersection before it actually is, and then we would be screwed, right? Because the SR latch would click into the reset position, and then it would never turn left at the intersection again, right? So the way I solved that issue is by actually adding a button over here. So this button over here, when you press it, turns on this light, right? So it sets it manually. So let's say if I made a mistake and I wanted to set again and I want to start the vehicle again, instead of turning off the power supply, I can just press this button. This puts it in the set position again. So essentially it means it hasn't passed the intersection yet because of this set button. And then as you can see, if I put it in intersection mode, it once again turns left at the intersection because of that light, because of the way we manually reset it. And I can demonstrate this once again by making it go straight again. It's going straight. Now I make it hit an intersection a second time by moving these wires over here, and it still stays in the going forward state.